Today we will learn the sampling distribution of a sample variance. Let x1, x2, etc. xn be a random sample which is taken from a normal population, normal mu sigma. Let x bar be the sample mean and s square be the variance. We can consider that the random observations are independent and normally distributed random variables with mean mu and variance sigma square. Now what does that mean? That means that xi follows a normal distribution with mean mu and variance sigma, where I is equal to 1, 2, 3, etc. up to n. Also, we can say that xi minus mu divided by sigma follows which distribution? Yes, standard normal distribution, that is normal 0, 1. Also, when I square this term, that is xi minus mu divided by sigma the whole square. Now what does this follows? Yes, this follows a chi-square distribution with 1 degree of freedom. And what about this one? Summation. If I take the summation of xi minus mu by sigma the whole square, which distribution does this follows? It follows again a chi-square distribution but with n degrees of freedom. Right, now this is you got this by the additive property of chi-square distribution. Okay, now also we know that x bar is the sample mean. Now what does x bar follows? X bar follows a normal distribution with mean mu and standard deviation of sigma by root n. Now this you have studied in your last class. We have also proved this, right? Now what is x bar minus mu by sigma by root n follows? What does this follows? Again this follows a normal distribution, but it is a standard normal distribution. Therefore you can also write this as x bar minus mu divided by sigma by root n the whole square follows which distribution? A chi-square distribution with 1 degree of freedom. Right, now all these things should be kept in mind when we move on to the derivation part. Now we will move on to the derivation part. Now consider the expression that I'm going to write below. Okay, now my expression is summation I is equal to 1 to n xi minus mu the whole square. Now this is the expression that you have to consider, which is equal to summation I is equal to 1 to n xi minus x bar. I'm going to introduce the term x bar into this this particular term. So when I introduce an x bar over here, I will have to subtract it, right? Minus mu the whole square. Now what I'm going to do is I'm going to expand this particular term. So when I do the expansion, what will I get? Summation I is equal to 1 to n xi minus x bar the whole square plus 2 into x bar minus mu summation I is equal to 1 to n xi minus x bar plus summation I is equal to 1 to n x bar minus mu the whole square. Okay, this is what I get when I do the expansion. Now this is equal to, now what is this? See, I hope you remember the formula of standard deviation. What was that? S square is equal to 1 by n summation xi minus x bar the whole square. Right, so which implies n s square is equal to summation xi minus x bar the whole square. Okay, so what can I write over here? Yeah, you can write ns square, then plus this term 2 into x bar minus mu multiplied by this term, this particular term. What is this? This is a property of what? Arithmetic mean. I hope you have studied this in your first semester. What does that mean? The sum of deviations of each observation from your mean is equal to 0. So using that property, this term is 0 and hence the whole term, the middle term, will become 0. Plus, what about this? This is n times x bar minus mu the whole square. Okay, now what I am going to do is, now this implies what? From where did we start? Summation xi minus mu the whole square is equal to ns square plus n into x minus mu the whole square. Now mark this as equation 1. Now what was your equation 1? Yeah, summation, I'm going to write it once again, xi minus mu the whole square is equal to ns square plus n into x bar minus mu the whole square. Now I am going to divide, this was your equation 1, right? Equation 1. Now I am going to divide the equation 1 by sigma square. So when I divide, I get summation xi minus mu the whole square divided by sigma square is equal to ns square divided by sigma square plus n into x bar minus mu the whole square by sigma square. Now is this familiar? Just think about the starting of this derivation. Do you remember what this is? Yeah, this follows a chi-square distribution with n degrees of freedom. So you can write this as, which implies chi-square distribution with n degrees of freedom is equal to ns square divided by sigma square plus, what about this? This follows a chi-square distribution with 1 degree of freedom. Yes. Now, which implies ns square by sigma square is equal to, or it follows chi-square distribution with n minus 1 degrees of freedom. Right, so we have seen the PDF of chi-square. You all know the PDF of chi-square with n degrees of freedom. Now what about a random? So this is a random variable. Consider this as a random variable, that is ns square by sigma square. Now it follows a chi-square distribution with n degrees of freedom. So how can I write the PDF of ns square sigma divided by sigma square? Yeah, it is equal to 1 by 2 the whole raised to n minus 1 by 2 divided by gamma n minus 1 by 2 multiplied by e raised to minus ns square divided by 2 sigma square ns square by sigma square the whole raised to n minus 1 by 2 minus 1. Okay, where now your random variable is ns square by sigma square, so this lies in the range 0 and infinity. Now see, what is our agenda, or what is our aim? Our aim is to find out the density function or the distribution function of s square, right? So in order to reach that point, what you have to do, now we have the distribution function of, we have the distribution function of what, or density function of ns square by sigma square, but we need the density function of s square. We have to find the density function or distribution function of what, sampling distribution, which is the distribution, we have to find that of s square. So for that, what we are going to do is, we are going to put u, a new random variable, is equal to ns square divided by sigma square. Okay, then what I'm going to do is, you can't simply put u is equal to ns square by sigma square, you have to differentiate u with respect to s square, so that gives you what, n divided by sigma square. Also we know that f of s square will be equal to what, f of u. This is a property that you have studied, f of u multiplied by modulus of, or the absolute function of du by ds square. Now this is equal to, I hope all of you know what is f of u by this time. We have written it just above, 1 by 2 the whole raised to n minus 1 by 2 divided by gamma n minus 1 by 2 e raised to minus ns square divided by 2 sigma square ns square by sigma square the whole raised to n minus 1 by 2 minus 1 multiplied by n by sigma square, which is equal to n by, now I'm going to club the terms. Okay, so n by 2 sigma square the whole raised to n minus 1 by 2. Now let's see how you can club the terms. Now you take the n's, wherever you find the n, you take that. So you have an n over here. What is that n? N raised to n minus 1 by 2, you have that with you. Then you have an n over here, so that n and this minus 1 gets cancelled. So here you can write n divided by, what about 2? Yeah, you have a 2 over here, so not sorry, this is e raised to that value, so you get n by, you have 2 here, right? So that is in the denominator, 1 by 2, so 2. Then you have a sigma square over here, sigma square, clubbing all these terms, I get n minus 1 by 2. Okay, the whole divided by, the gamma function is written like that itself, multiplied by e raised to minus ns square divided by 2 sigma square. Then what about s square? S square is x square raised to n minus 1 by 2 minus 1. Okay, so and here 0 lies between, s square lies between 0 and minus infinity. So this is the density function of your s square. Thank you.